All right, everybody. So this is the August 2019 Regents with a multiple choice August 2019 Earth Science Regents. We're going to start with number one. So number one says most asteroids in our solar system are located in the asteroid belt between the orbits of Mars and Jupiter. Mars and Jupiter. So that's something we got to keep that in mind. What is the approximate distance from the sun to the asteroid belt? So what page of the reference tables do we see where we know for a fact that it's talking about Mars, Jupiter, and other planets? What page are we going to focus on? Page 15. All right, so let's turn to page 15. So if we, sorry about that, hold on. If we turn to page 15, all right, and we know the distance of Mars is going to be from the sun is 227. We know the distance of Jupiter to the sun is 778. So therefore, if the asteroid belt is going to be between Mars and Jupiter, then therefore the asteroid belt has to be a number between 227.9 million kilometers and 778.4. So which choice gives me a number in between 227.9 million and 778.4 million? And it's going to be choice 3. 403 million. All right, since the asteroid belt is between Mars and Jupiter, you have to look at the distance between Mars and Jupiter. Let's take a look at number 2. So number 2 says, the table below shows tide data for a location on the North Shore of Long Island in New York State. They give us the high tide, and they give us the low tide for Tuesday and Wednesday. Based on these data, what is the most likely time of the next high tide? So one thing you have to remember is that when you go from a low to high, from a low tide to a high tide, is going to be a little over 6 hours estimate. And it's the same thing if you go from a high tide to a low tide, all right? If you're going from a high to a high tide to another high tide, approximately, this is an estimate, about 12 hours, 25 minutes. Now, keep in mind, this is an estimate. The same is true if you go from a low to a low, all right? So we know low to high and high to low is a little over 6 hours, high to high and low to low, 12 hours and 25 minutes. So if my high tide is Wednesday, 1:27 p.m., right? What is the most likely time of the next high tide? So high to high is going to be another 12 hours right now, right? 12 hours and 25 minutes from 1:27 p.m. So 12 hours from 1:27 p.m. gives you 1:27 a.m. And then 25 minutes later from that would give you 1:53 a.m. And so the best answer is going to be choice 1. So you have to remember, the rule is to go from a low tide to a high tide, a little over 6 hours, high tide to another high tide, a low tide, 12 hours and 25 minutes. Let's take a look at number 3. So number 3 says, which planet takes longer to complete one rotation on its axis than it does to complete one orbit of the sun? So remember, one rotation on its axis is talking about the period of rotation. One orbit, how long does it take for a planet to do one orbit around the sun? That is the period of revolution, right? Orbit refers to revolution. So they want to know what planet is the period of rotation, has a higher period than the period of revolution. There's only one planet that has that, and if you look on the reference tables, the only planet that has that where the period of rotation is higher than the period of revolution is Venus. You see, Venus has 243 days as period of rotation, period of revolution, 224.7 days. And that's why the correct answer is choice 2. Let's keep it going. All right, number 4. Jupiter is a Jovian planet. Compared to terrestrial planets, Jupiter has a what? So remember, if you have forgotten, the first 4 planets of the solar system are your terrestrial planets. I'm just going to label T for terrestrial. Your last 4 planets of the solar system is going to be your Jovian planet. I'm going to label J for Jovian. So compared to terrestrial planets, Jupiter has a what? So shorter period of revolution. It can't be that, because if the Jovian planets are the last 4 planets of the solar system, if you take a look, their period of revolution is in years. The terrestrial planets' period of revolution is in days, right? So Jovian planet takes much longer to go around the sun. Jovian planets do not have a shorter distance from the sun because Jovian planets are the last 4 planets of the solar system, as we stated here. Jovian planets have a greater distance. No, that's not the density. That's not the case, because if you look at the density, right? All right here, all Jovian planets' densities is less than 2. And for terrestrial planets, all, sorry, not including the sun, all terrestrial planets has a density of greater than 3. So it can't be that. So therefore, they do have a greater mass. If you take a look at the mass of Jovian planets. If you take a look at the mass of Jovian planets, all right, we see right here the mass of Jovian planet 317, 95, 14, and 17, right? And then when we take a look at the terrestrial planets, all of them is 1 or less. So that's why choice 4 is the correct answer. All right, let's take a look at number 5. So the entire constellation of Orion, is visible in the night sky in January to an observer in New York State. Which statement explains why this constellation is not visible in the night sky to this observer in June? So we're looking at a night sky in New York in January, and we're still in New York, but this time it's June, and we don't see the same constellation. Remember, constellation is just a group of stars. It's a group of stars. All right? And we know that the group of stars that you see in the nighttime sky changes throughout the year. That's why, right, when you pay attention to those astrology signs, right, Aries, Cancer, Capricorn, all right, all these different zodiac signs, right, they are given different months out of the year because constellations are seen, different constellations are seen throughout the year. So which option focuses on the fact that the Earth is moving around, right, changing its position, and something that is occurring throughout the year? The only choice that shows that is choice 2, right? We see different constellations because the Earth is revolving around the sun. Let's take a look at number 6. Number 6 is a memorization question. The approximate age of the universe is estimated to be, and this is just a factual question, is 13.8 billion years. I know that depending on where you've learned this. Some people may say 13.6 billion or 13.7 billion years. All right, but you want to choose the best answer for your multiple choice. That is for number 6. Number 7, it says a photograph below shows the apparent path of the sun photographed at 20-minute intervals and combined into one photograph. Which motion is responsible for the apparent path of the sun shown in the photograph? So we know that the path of the sun, the apparent path, right? So obviously the sun is not physically moving throughout the day. It just appears to be that it's moving. So which motion is responsible for the apparent path of the sun shown in the photograph? Because we know this is taking place throughout the day, right? Throughout the day, keyword is day, there's one movement of the earth that focuses on day and night, and that is the Earth's rotation. Choice 1. Right, the Earth's revolution occurs, right? The Earth goes around the sun once every year, right? We have night and day. We see that the sun appears to move throughout the day because the Earth is rotating. All right, check. All right, check the other videos so to see the rest of the answers. Have a blessed day.